Hello everyone, welcome to switispeaks official YouTube channel. I am Sweetie Pinjani. This is UVM Basics series. In case you have not already gone through, we had already covered some topics in UVM in the previous lectures in this series, which is UVM Basics, uploaded on switispeaks official YouTube channel by Sweetie Pinjani. There is a video lecture on UVM introduction, UVM components, UVM test bench architecture. Please go through that. This next lecture is a continuation of those. Today, we are going to focus on a very important topic on UVM, which a lot of people will even ask you. This question you may get frequently if you add UVM as a skill, which is necessary for verification engineers. You should know what is UVM factory. In simple English words, what is factory? Factory is something where manufacturing happens. What kind of manufacturing can happen in UVM? Think. What are the things in UVM? We already saw in the previous lecture. First thing is components. UVM has a lot of components like driver, monitor. All these are components. They need to get manufactured. The next thing which needs to get manufactured is UVM objects. What are different kind of UVM objects? One example I'll give you, UVM sequence item. That is an object. These components and objects need to be created in the UVM. This is done using the UVM factory. In simple English words, we understood the meaning of factory and we understood what is that thing which needs to be created in UVM, which is objects and components. That's what is created in UVM factory. Very, very simple to understand. Now, the important purpose of the factory is it enables an object of one type to be substituted with an object of derived type. I'll give you a simple example. UVM has a lot of inbuilt component classes. It has a lot of inbuilt object classes. For example, UVM has an inbuilt class for driver called as UVM driver. Whenever you want to create a driver, you can extend your class from the UVM driver, and whatever functionality is available in the UVM driver, that will come in your derived class. This is the main purpose. It will help you to substitute an object of one type with an object of derived types, which you will need a lot in the UVM. Main purpose. Next, you need to understand, to do this, you need to do this without changing the test bench structure or the test bench code. Those should remain same. Still, you should be able to substitute your objects. This is the main purpose of the UVM factory. How are you going to substitute the objects? There are two ways. You need to override, either by instance or by type. Override by instance or type. These are the two ways. UVM factory will also allow you to change the sequence behavior. This is also required in UVM because you have a lot of SOC test to run in which the sequence behavior needs to change throughout the simulation. This is where UVM factory will help you. Next thing is you should be able to replace one component version by another. There are some important things to take care. First thing is component should to be swapped should be polymorphically compatible. I'll give you one example. There is a component which is of type driver. You cannot swap that component with sequence item. It is not possible. They are not polymorphically compatible. Driver can't be replaced by sequence item. Driver can be replaced by some other driver. This is what you should understand. Next point is all TLM interfaces and TLM objects need to be created by the replacement component. Whatever replacement component you want, all the TLM interface handle and TLM objects need to be created in that component. What is TLM? That is transaction level modeling, which we use in UVM. We will cover this TLM in detail in the upcoming sections. Now understand it is transaction level modeling. That is the full form. This is a gist of UVM Factory. There are some very strict coding conventions in UVM. Since UVM is a methodology, we need to follow the method. All the coding conventions which are specified by UVM for UVM Factory need to be followed. We will see what are these coding conventions now. First coding convention is registration. Whatever UVM component or UVM object you have, it needs to be registered with your factory. The factory registration code for your component or object. You can register component or you can register object. What that code should contain? First thing it should contain is a UVM component registry wrapper. It needs to be type def to the type ID. All these are strict rules by UVM. The format you have to follow as it is. So first thing is you should have a wrapper, UVM component registry wrapper, which is type def to the required type ID. Next is you should be able to get that type ID. That's why a static function to get the type ID. And you should also be able to get the type name, a function to get the type name. Three requisites for registration. First is you need UVM component registry wrapper, which needs to be type def to the type ID. You need a static function to get the type ID, and you need a function to get the type name. These are the three prerequisites. Now let's see an coding example for factory registration. I have a class UVM factory component which extends UVM component. It means this is of the type UVM component. It is a component, not an object. Here, as we said, first you will need a UVM component registry wrapper, which is type def to the type ID. This is the first prerequisite. Here, if you see in this code, type def, if you don't know what is type def, I have covered about this type def already. You can go through System Verilog tutorial series. There is a detailed lecture available on type def along with the code. You will understand what is this type def. Type def is majorly used to create user defined types. This is type def, and as we said, it is UVM component registry. This is UVM component registry, and these are the IDs and name. I am using the same ID and same name, UVM factory comp. This is the ID and the name, and type ID. This syntax you have to follow as it is. Only the ID and name you can give whatever you need, but this syntax you should follow as it is. That is how it should be in UVM. The syntax is fixed by the UVM. The second requirement was you should have a static function to get the type ID. I'm creating a static function type ID to get the type ID. So it is get type. The name is get type. And it is returning the type ID. It is calling get and it is returning the type ID. Here, if you see the type def which I created, the name of that type def is type ID. Same should be the return type of your function because it is going to return this type def which you created. This and this should match. You can give any name, but whatever name you give here should be the same return type. And then call the get method to get that type ID. Then the third requirement was you should have a function to get the type name. Type name will be of type string. The data type will be string and you are naming the function as get type name. Here it is returning the name. Here if you see the name I have given UVM factory comp. I have given the ID and name same UVM factory comp. That is my name. That's why it is returning the string variable called UVM factory comp. That's it. These are the three prerequisites. You will have UVM component registry wrapper, a function to get the type ID, a function to get the type name. This is about the factory registration. Then you will end the function and end whatever class you have. That's the code. Now let's see how it works for the component. There are some macros which are specified in the UVM for doing registration for the component. If you want to register a component class, what is a component class? We had discussed this in, if you remember, in this series itself, UVM basics, we have a tutorial on UVM components. In that we have discussed what are the different UVM components. There can be driver, monitor, agent, and these are the inbuilt classes inside the UVM driver, UVM monitor, UVM agent, UVM component. Anything which is derived from this becomes the component class. Say I am creating a component which extends from UVM component. The name is UVM Factory comp. If I want to do registration for this component using the macro, UVM provides me a macro called as UVM component utils. This is the UVM component utils, and you will pass the class, whatever you have, UVM Factory comp. This is the syntax. As I said, in UVM, syntaxes are strict. You have to remember the syntax. You have to remember what is the macro. You can go through this tutorial again and again, practice by yourself. These things you have to remember. UVM syntaxes are strict. So if you want to register a component, you will call UVM component utils, pass the component. This is the syntax. What if your component class is parameterized? It is possible I want to give certain things like say address width and data width in the form of parameter. Here is an example. I have the UVM factory param component. And here I am taking two parameters. One is address, which is 32-bit. I am passing 32, and data width, which is 64. And it extends UVM component. In this case, UVM is providing you UVM factory param component. You are creating a type def UVM factory param component. You are passing the parameters address width and data width, and you are naming it something. I named it as this param com. This is the name. And this is the type def which you created. And here for parameterized, you have to call UVM component param utils. For component, it was UVM component utils. For parameterized component, it is UVM component param utils, and you will pass whatever type def you have created. This is how it works. This is the syntax. Now let's see what happens for object. If you have an object class, what can be the object class? Again, in UVM itself has a lot of inbuilt object classes like UVM transaction, UVM sequence item, UVM sequence, or anything which is derived from UVM object. All these will become the object classes. I have an object class. I am creating an object class which is extending UVM sequence item. This is UVM factory item is the name of my class. UVM is providing me a macro UVM object utils, and here I will pass my class. This is for the object class UVM object utils. And if you have a parameterized object, this is your UVM factory item, but this time it is parameterized. Again, address width and data width I am taking as parameters. In this case, again, I'll create a type def. I'll name it UVM factory item. I'll pass the parameters. I'll give it a name, this param com. And then UVM is providing me UVM object param utils. And I'll pass this type def which I created. Simple to remember, not complicated. There are 4 macros. 2 is for component and 2 is for object. For component, we have UVM component utils. If you have parameterized component, you have UVM component param utils. For object, you have UVM object utils. If it is parameterized, you have UVM object param utils. That's about registration. This is first coding convention. The next coding convention which you should follow for the UVM factory is the constructor defaults. While constructing the UVM factory, you will have a constructor, and there are some defaults which you have to follow. Let's understand what are these. You need to first understand that UVM component and UVM object constructs are virtual, and they have a fixed prototype in UVM that must be followed. As I said, UVM prototypes are fixed. You have to follow the syntax as it is. You can practice it, see it a few times, write it by yourself. It will be clear in your mind. It's not that difficult. Then every derived UVM component or UVM object class must call super.new method. As I showed you, I was deriving a sequence item. I was deriving something from UVM sequence item. In that case, I have to call super.new method also, in case of any derived component or the object class. We will see the code, but remember these points. They have fixed prototype and they should call super.new method. Now, some more things to remember. Constructor defaults for a component. In the component, you will have two arguments. One is the name and parent. Name and parent. In object, you will have only one argument, which is the name. These are some things to remember. Let's understand the code now. For the component, what will happen? I told you here, if you see, I am again extending UVM. Factory comp is the name of my component class. It is extending UVM component. What we said, it should have two default arguments, name and parent. This is how we give. This is your constructor new, where you are passing the name and parent. You can also assign parent as null. This is your constructor new, and you are passing name and parent, and you have to call the new method also. As we said, super.new you have to call, and there also you have to pass name and parent. And that's it. Then for object, this is UVM factory item, which is extending UVM sequence item. It is object. What we said, it will have one default, which is the name. Here, if you see, there is just one default. The name is UVM factory item. This is the name. And then we have to call super.new and pass the name. That's it. Simple. Constructor default is very simple. For the component, you have to pass two arguments. One was name and parent. You have to call super.new. For object, you have to pass only one argument, which is name, and you have to call super.new. That's it. The third coding convention is for creation. Creation is where your actual creation will happen in the UVM factory, and we use the create method. Let us understand. Use the create method of the wrapper, which is the wrapper we were using, UVM component registry. It has the create method, which we will use to do the creation. For component, what we have to do? We have to do the creation in the build phase. For component, it will happen in build phase. And the process for the component is top down. Build will happen from topmost component to whatever are the subcomponents, top down. Why? Because we want to allow the higher level component and configuration to control what actually gets built. That's how it makes sense. You have to construct the top first, and then down whatever is inside. That's how we do inside the creation of the component in the build phase, top down. For the object, it happens in run phase. Remember this. We have to use create method. For the component, it will happen in build phase. We will follow top down approach. For the object, it will happen in run phase. Let's see example. How does creation of component happen? For the component, you will first have the component class declaration. Like we said, we are extending some class from the UVM component. That is how you declare. And then whatever we saw, the factory registration code will come. Then the constructor default, that code will come. And now let's see how the creation happens. As we said, for component creation should happen in the build phase. Now this syntax is also fixed. We will also have a tutorial on UVM phases in the upcoming sections. But whatever syntax is there in UVM, that is fixed. You have to use this syntax only. Function void, it is of type void, build phase, and then you have to pass UVM phase. That's how it is the code in UVM. You have to remember this. You can practice and remember. This is the build phase. In the build phase, we have to create the component. This is the syntax. Say your component is factory com and it is of type UVM Factory comp. So here at the top, you would have already said UVM Factory comp extends UVM component. That would be your class UVM Factory comp extends UVM component. That class comes here, UVM Factory comp. This syntax is fixed. You have to use this syntax, type ID, and then create. And in case of component, what we said, we need two arguments, name and parent. This is the name factory comp. This is the name factory comp. And this means this class itself is the parent. These are the two arguments in the create. Create, your name and the parent. This is the syntax. And what if you have parameterized component? If you have a parameterized component, you have to follow the same syntax, just you have to pass the parameters. Here, whatever is the name, factory param comp is the name. The component, there you would have created my param component. That would be the name. At the top, you would have created my param component extends UVM component that. And whatever is the name that will come, and whatever argument, say you are giving 32 only, your address is 32, your data width is 32, address width is 32, whatever you want to give, that you will pass. Type ID, create, and again you will pass the name and the parent, name and parent. The syntax is fixed. Only things that can change is these names. Whatever name you have, name you want to give, the class which you created, the parameters which you want to give. This is fixed. Type ID, create. This is how you have to give. And here also this name can change, the parent can change. This syntax is fixed. This is how it can be. Only the names, parameters, and these arguments can change. Practice it. It's not so difficult. If you practice few times, you will remember all the syntax. And that's the build function. For component, we do it in the build phase using the create method, which will take two arguments, name and the parent. Now let's see the creation of object. First, you will declare the object class. As we saw, if I want to extend some class from the UVM sequence item, whatever name I give, then I'll register it with the factory, and then whatever constructor defaults I want to give. For the object, it happens in the run phase. Run phase is a task. Remember, run phase is a task in UVM. You have the task run phase, UVM phase. This is the syntax of run phase. You have to follow as it is. It's a task run phase, and this is the argument UVM phase. Then you have a UVM factory sequence. You had already declared a class UVM factory sequence extends UVM sequence item, that you have already done at the top. Whatever name, you are creating an instance. You are creating an object. Factory sequence is the name of your instance. This is the object. And if you want, you can also have a parameterized object. Here, UVM param factory sequence. This one is a parameterized object which is having address width and data width. Whatever address and data width you want to give, it's your wish. And then you have a param factory sequence. This is the name, param factory sequence. This is the name of your parameterized object, and this is the name of your object. Factory sequence is the object, and the parameterized object name is param factory sequence. If you want to create an object, you have to call create. The syntax is whatever name you want to give, factory sequence you have given, this factory sequence you have given, this is the instance which you have created, right? Factory sequence, whatever instance you have created comes here. You are going to register this with the factory, whatever name, this name and this name should be same. And this is the syntax. Now at the top you have created a class UVM factory sequence extends UVM sequence item. That name of the class comes here. Type ID create, the syntax remains same. And here the name, whatever object name you give, this it will come from here. This is how you create the object. Syntax you have to follow as it is. Similarly, for the parameterized object, what we will do, everything remains same. You can give name whatever you want. Whatever class you have created will come here. Only thing is you have to pass the parameters. Whatever parameters you want to pass, it's your wish. And then this is again fixed. Type ID create. Type ID create and whatever name you want to give. Param factory sequence you are giving. So this is param factory sequence. You would have given here param factory sequence. If you see param factory sequence, the same name comes here. This is how you have to create the object. That's it. The task ends here. Go through this lecture a couple of times, then practice by yourself. Once you practice a few times, it will be easy. I have explained it point wise, step wise. First, remember all those steps. There were 3 coding conventions. Which were they? One was you have to register. Second was you have to give some constructor defaults. And third was creation. Practice all this. UVM Factory, you will understand. We will see a lot of other UVM concepts in the upcoming video lectures. To stay tuned, you can subscribe to Switispeaks official YouTube channel.